Okay, welcome to the next design patterns and framework session. Today we are going to discuss another new design pattern called state design pattern. So if you look at the where we are right now, we have discussed 8 design patterns. Today we are going to discuss the ninth design pattern. So we have discussed factory and singleton design patterns from congregational design patterns, adapter, decorator, facade, and proxy from the structural design patterns, and chain of reaction template from the behavioral design pattern. And today we are going to discuss state design pattern, which is a behavioral design pattern. As I said, it's a behavioral design pattern. It decides how your objects are behaving in the in a different context. So this design pattern is a little strange design pattern, I would say, than others. This is primarily used when you need to change the behavior of the object based on their state. So every object can have different state. This state design pattern will govern the behavioral factors of the object for different states. So let's do it from an example. This is a very common example that is used in the literature, vending machine. Now in a vending machine, as you know, when you insert a money, dollar, then you get your request product, you request for product, and then you get the necessary product. That's a whole applications of this particular vending machine. So if you look at in this particular vending machine, there are 3 states. One is idle. You have the stock, but no one is using it. So that's idle state. Then you have another state that is after you insert a dollar, machine has a dollar. That's another state. If this particular machine does not have any stocks, that will be taken as a out of stock state. So you have 3 states in this particular example. Next important thing is how the state changes from one to the other. That is, you will have triggers. So when you insert a dollar, state will change from idle to has $1 state. And if your vending machine has one item, quantity is 1, then it will dispense this item to you, and then this vending machine will become out of stock state. In the out of stock state, can go back to the idle when you fill the vending machine. And also, if you has $1 already, and if there are no products, if there is items more than one, it will give you the item and return back to the idle state. So you can see there are 3 states as well as multiple trigger events. Then we have actions. If you have a $1 and your item count is larger than 1, you will release the product. If you are out of stock, if someone insert a coin, dollar, you will return the money. So you can see, so we are basically linking 3 things in this design pattern. One is state, other one is triggering points. triggering events, and then the behaviors. So vending machine, so vending machine class will have a constructor called vending machine, and you have a input parameter for the, when you're creating the object from a vending machine, you need to say, okay, how many items are there? Quantity should be provided. And then there are three events. You insert a dollar, money will come out, and then you dispense the items. You insert a dollar. If there is a dollar, money will come out, eject money. If there is, uh, if you have insert the coin, and the next event would be dispensing the relevant item. So you will have those three events as well. So how do you do this in traditional way? Forget about the design patterns. If you are asked to do this, how we are going to do this? So we will create a class called state. And for a given vending machine, you can have only one state. You can have only one state. So when I state only one state, what does that mean? Any relationship with design pattern, some design pattern we discussed before? Yes, singleton design pattern. So in this method, what you're going to do is, the traditional way what you're going to do is, you're going to implement a singleton design pattern for the state class. So this is how you implement the singleton design pattern. Every time new state will override the existing state. So you will have three state: idle, has a $1 and out of stock state. Then your vending machine constructor will change. So if the item count is greater than 0, you will set the state to idle. And if the count is 0, you set the current state to out of stock. That is when you are creating a vending machine object. Right. So then you insert a dollar. So let's see how you are going to implement the insert dollar event. If the current state is idle, and during the insert dollar, the current state will become has $1. And if the current state is, you already have a $1 and you are inserting another dollar with this method, then you return the money and you are saying current state is idle. And if it is out of stock, if the state is out of stock, you return the money. You don't have to set the state to out of stock because it's already out of stock. That is why you are returning the money. So your state of the this state would be again back to out of stock. So there is no point of saying current status equal out of stock because it's already out of stock. Right. So this is how you do it. Now, how can we use state design pattern? Now, this is why I said at the very beginning, this is a little strange design pattern. Now, typically we create objects, classes. We create classes for a tangible objects. For example, bank account, person, vehicle, animal, so on and so forth. Here we create classes for states. Here we create classes for state. Now, so you will have an interface called state, yeah, where you will have these trigger events, insert dollar, eject money, and dispense. And then there are concrete state classes, which are implement from the state interface. So we haven't done that type of implementation before. Right. So then what we do is, so your interface is very simple. You will have three method signatures. You are inserting a dollar, passing the vendor machine. You are eject money, passing the vendor machine. Your dispense item, passing the vendor machine. So those are the three methods in the or method signatures in the state interface. Right. Now let's see how we can implement each. If I go back, so we have to implement all these three classes for each state. Right. So we have an idle state. We are implementing from a state. Hope you remember the keywords. This interface. So if you are implementing a class from an interface, we have to use the keyword called implements. So when you say implements, you have to have a concrete methods for the classes that are referred in the interface. You have to implement those things. So you can say that. So this is idle state. Once you insert the dollar, you are setting the vending machine status to has $1 state, right? And if the eject money, then what you do is eject money method. So it's idle state. It's idle state. So when you eject money, there is nothing to return. Dispense. If you know the ideal state, you have not the dollar is inserted. If someone just press the dispense key or whatever, it should say you need to pay. Payment is required. So you can see simply those three methods are handled in the ideal state class. Then has $1 state class. So when you insert a dollar, now has a $1 state means you already have a dollar. When you insert it, you are saying, okay, I do have you already have a dollar, and you return that money, and state would be idle state. Then you eject money. Here you have the, unless in the previous one you don't have an eject money method, right? There's no money to eject return. So here you will write the return money or eject money steps. Then finally dispense. So what happens is you insert the coin, then you dispense the item. So when the dispense item is, when the status is, when you do the dispense item, it will check for the item count, whether the items are available. Then it releases, and then the status set to idle. But if the stock is uh, not greater than 1, that is less than 1, you set to out of stock state. And you release the item because it's not 1. It's 1. So you have to release that item and set the state to out of stock state. So that's the implementation of has $1 class. Then we have one more. So similarly, we need to do the other class as well. Now the next point is, how do you call these multiple states? So here, this is in the vending machine, you handle it. You have the three states are there, and you look at the current state. So here the vending machine constructor. So you start with the, you are starting the method with saying that it's idle state, and has dollar state. So these are the three states. So depend. So you are defining three states here, and if the count is larger than 0, you are setting it to idle state. You can, this is a nice way of writing. You make the need state, these are the states that you're going to handle, and then allocate depending on the need. And if the count is not greater than 0, that is uh, less than or equal to 0, so then it is, you are saying your current state is out of stock, and you are making the count to 0. Right. So then again, you write these three methods: insert dollar, eject money, and dispense. So this is a high level UML diagram. You will have concrete states which are handled by the main state interface. And then in this case, the depending on the state, the main, in case vending machine, right, it handles through the using the different concrete state classes. Another example, TV button, right? You press on, off, and mute button, right? So those are the states that you have for television. So in here it says, how do you change the status from one to the other? Off to, when you press the on button, off to, it goes to on. When you press the off button, it on from on state, it will come to off state. When you on mute, when you press the mute button, from on, it will come to the mute button. But can you see from off, can you have a mute, can you go to the mute state? No, you can't. From the off state, you can't go to the mute state. When the television is off, you can't mute it, right? So that part is not available. You can see in all the other status, there are back and forth mechanism. From here, you can go back to on. From on, you can go back to off. From on, you can go back to mute. From on, you can go back to mute. From mute, you can go back to on, but not from off to mute. So that is a very important thing. You need to understand how these state transitions are happening. What are the valid state transitions? Right. Let's take another example. Health condition of a human. So how many states that you can have? Injured, sick, recovering, healthy, exercise. So you can have a lot of status. But let's for purpose of explaining this, let's step to three state: healthy state, sick state, and the critical state. So what are the key considerations for state design pattern? One thing is, you need to understand the state relationship. Now, if you look at the previous example of the human, the well-beingness or the health, now state transitions should be encapsulated within the class. How this state is changing from one to the other. And within the state, you set the behaviors. Within the state, you set the behaviors of these particular status. So each state class should define only the behavior valid in that state. Now, some behaviors may not be valid. For example, classical example is when the TV is off, you cannot mute it. That behavior is not valid. So, so you need to understand what are the valid behaviors. And also, if you do not use state design pattern, you will have to write all these combinations in if conditions, if else likewise. But because of this method, now you don't need multiple if methods. Another rule is the state transition should be explicit. It should come from one state to the other, not in between. You have state A, it should come to the state B, not in between. Then, number of states, you should have finite states. You can't say fuzzy state, combination of multiple states cannot be there. Then, the states can be extended. So you should write your code with minimum code changes, avoiding if you have too many states and transitions, it may be complexity may rise. So it's better to simplify the states by using some grouping technique rather than try to apply all these status and transitions. Performance. Now, each action involves delegation to a state object. usually negligible, but when it comes to critical systems, if you have too much of transitions, it might add some performance. It can have a performance impact to the your entire system. Right. So again, this health state example, person context delegates behavior, that is work, rest, exercise, to the current health state. Each state, healthy, sick, critical, defines what actions are possible. Transitions are very clear. Sick to critical, sick to healthy are handled inside state classes, keeping the logic clean. So there cannot be a situation from critical to healthy. You cannot have the state transition from critical to healthy. It should be healthy, sick, sorry, critical, sick, then healthy. Right. Another important thing, when to use and when not to use. So let's go by the when to use. This object's behavior changes significantly depending on the state. So here, if the object behaviors change significantly because of the state, okay, classical place where you can use the state design pattern. And if you have too many transitions where you handle it from if conditions, another good candidate for state design pattern. If the states are well defined, transitions are well defined, that's where you can use state design pattern. Uh, so if you want easy extensions, that is in future there can be multiple states can come. So then that is another place where you can use the state design pattern. So this is normally helpful for workflow systems. So you can see it's going from one place to another, and then it can return, right? So likewise, we can use the state design pattern. User accounts, because sometimes user accounts get locked, user accounts get disabled, right? So depending on that, the state can change. As I said, health status also another good candidate for uh, the state design pattern. Okay, when not to use, where we should not use state design pattern. Now, if you have very simple states, two states, right? So, and behaviors didn't change much, whether if you state 1 to 2, still the same behavior. So, nothing much you can do with the state design pattern. And also on the other hand, number of states are too large. This is called state class explosion. If you have too much of states, that will end up with large number of classes. And there can be situations where states are dynamic, fuzzy. That is means it doesn't have a clear state. Now, if you look at your washing machines, you have a wash, rinse, and dry. So three different states. However, in the latest or not latest, the recent washing machine, you have something called fuzzy. That is in between two states. While washing, they do the rinse as well. That's called fuzzy. So if your states are not clearly defined, that is not the place you can use state design pattern. Uh, if your status are not extending, you are pretty much sure that these status will stay as it is, then you should not use template rather state design pattern. Uh, and sometimes there can be situations where all behaviors are same across different states. If that is the case, no point of using state design pattern. So the golden rule is, if you find yourself writing alone chains of state equal this, right? If you have large number of codes, you're writing state equal this, do this, this, this. If the state equal this, you do this, this, this. Now that's a good candidate for state design pattern. And if the states are very few, less than 3, and unlikely to change, then stick with the simpler logic. So that's about the state design pattern. With that, we have covered 9 design patterns. So again, reflective questions. How does the state design pattern improve code organization compared to using multiple if-else or switch implementations? Can you think of a real world example? So you can bring your projects here outside the classroom where the state pattern could simply handle different behaviors of an object. Why would this pattern be useful there? And what are the potential drawbacks of using state pattern in a system, and how can a developer decide whether it's worth applying in a given situation? So think like a developer, how these questions can be answered with respect to state design pattern. Thank you very much. Let's see you in the class.